Thank you, Bill, again. So it was
questions.
a very interesting presentation, and now is the time for question and answers. Yeah, the first question was whether you can elaborate a little bit more on the phase conjugate mirror. What does that mean?
Well, what you do is you set up two electromagnetic pump waves, and you pump your material, okay, with this. And the material here is, of course, this iron, okay, the transformer iron material. And you pump that just by using opposing magnetic fields. And so the magnetomotive force is what we're working with here. And when that's set up in an opposing configuration, okay, creates this what's called a phase conjugate mirror. And that's what Tom Bearden called it in his lectures, okay? And what that phase conjugate mirror does is that it sets up a time reversed output, okay? And that's what we use to drive our technology with. And so on our output, we see this phase conjugation occurring, which is a time reversed wave, or the sine squared term becomes time reversed. Okay? And that phenomena actually happens. I mean, I see it on our output, on our device, and what it does is that it decreases the input current requirement on this device. And that's why I show this kind of a reverse profile on our input current, okay? Because it actually decreases when you reach the resonance on your output capacitor and your output of this transformer arrangement, okay? You see this dip in your current input. And so when you do the power calculations, you find out, lo and behold, your efficiency starts to go way up, okay? Now on my transformer, the coils are not tuned, okay? They're just straight opposing coil configurations. When you look at Stanley Myers, he was able to tune his output coils and match them as close as possible. And that's what you want to do, is to match the output coils such that you get as much cancellation as possible. And when you do that, your input and output, when you do the efficiency calculations, go way up, okay? And it can easily exceed 100%. Now with mine, split flux transformer, the coils were not tuned. They were just straight coils. And I observed an increase in efficiency. And my increase in efficiency was able to go up to 90% efficient, when typically a transformer input-output coil arrangement, your efficiencies are right around 75, 80% efficiency. So I observed an increase in my efficiency output. Now, if I was able to balance those coils properly, okay, I could have that efficiency very easily go way over 100%. And that's what was observed in a number of these technologies that use this opposing coil arrangement. For example, Stanley Myers and his water car. You observe like 1,200% efficiency with this tuned coil arrangements. And Floyd Sweet, with his device, observed something like a 10 million% efficiency. So that means his input current was rapidly approaching zero, okay? And he was producing that scalar wave output. And so this is what you want to do, is to be able to tune those coils, okay? Increase your efficiency.
Very good. So Do we have some other question to Bill? Right. So there is a new question, right? What is the effect of PCM on split flux transformer performance exactly? I think that's what you probably already explained, right?
Yeah, yes, that's what I was showing in the slide, is that right around 90%, and the coils are not tuned.
Right.
Okay.
Very good. So thank you very much for this inspiring presentation. I wonder if you have a detailed description in order to replicate the over-unit burning of water. That's probably a question related to Stanley Meyer, right?
Right, yeah. Max Miller, okay, was a presenter at Tesla Tech conference about 4 or 5 years ago. And he gave an excellent presentation replicating Stanley Meyer's water car. I mean, he replicated all the circuit boards and his transformer, um, and it was highly efficient. He was able to tune his transformer, and he did an excellent job with that replication. And he was able to hook up his transformer to these water capacitors producing Brown's gas. Okay, and that's what you want to do here, is use scalar energy, okay, for producing this hydroxy gas, and that's what you want to run engines with. And then some researchers in Phoenix, um, they didn't replicate anything what Stanley was doing or any of these scalar technologies, but they were just using a straight power supply, which of course uses a lot of power to make the hydroxy gas. And they observed in their engines, okay, because you feed this as you replace your air input on a gasoline engine, okay, you place it with a hose feeding this hydroxy gas right into your air intake, okay, on these gasoline engines. And they observed very high efficiency, okay, of burning this hydroxy gas, okay, in their gasoline engines. So it drastically reduces any sort of pollutants, okay, associated with burning hydrocarbons. So that would be the way to go with this. I mean, they were using a full engine, a gasoline engine, to do all this testing with.
Thank you. So, Dr. Alek, thank you for your excellent presentation. As far as I can recall, at several occasions, Dr. Tom Burden refers to Tesla electromagnetic theory as a cold electromagnetics. Would you mind to clarify what is cold electromagnetic force that he meant to refer to Tesla work?
Well, this is where the PCM comes into play, and producing this time reversed wave. And we see that electromagnetically, okay, as a scalar wave output. That's your sine squared term. And then we also see that with the anti-gravitational component as well. Okay, that's producing this wave number 5 on the PC. If you look at the PCM diagram here, the 5th wave is being emitted by the device itself. And so what Tom referred to is that it's all coming from the zero vector. Okay, when you do the calculations with the Oliver Heaviside electromagnetics, the zero vector is empty. Okay, but when you look at the original James Maxwell's equations, they include the scalar component, and your zero vector is not empty. It contains this what Tom calls a vacuum engine. And this vacuum engine is what's doing all this magic, okay, of producing this time-reversed scalar EM wave and this time-reversed gravitational wave as well, okay? And this is what we want to use in our technology, is this scalar wave technology to improve the efficiency of our machines. So
Thank you.
this cold EMF, that's all part of this PCM that Tom was speaking about.
And there is one more question. And secondly, what kind of equations referring to those Tesla experiments? Question mark. Thank you.
Okay, now I really don't know much about what Tesla was doing with any of his equations. He just spoke about the effects, you know, some of the effects that he observed, and it's my opinion that Tesla was using the scalar wave technology, you know, because it's just how he described some of these effects. For example, some of his waves, he mentioned, move faster than the speed of light. Okay? And we're all doing that with canceling out the magnetic component in these waves. That maybe it reduces or eliminates the speed of light barrier, okay, in electromagnetics. Because that's what we're really stuck with, is that when you work with Oliver Heaviside's equations, you're stuck with the speed of light. And I think when we look at Tesla and what he described, and when we start looking at Tom Bearden's technology as well, you start to overcome these limitations. You know, and it's exactly what they did when they conquered the speed of sound, right, with their aircraft.
Right, Bill, there is another question. Can you please explain in more detail how the Floyd Sweet device and your further development produce anti-gravity?
Okay, Floyd Sweet, very interesting character. He lived in California. I think it's Rex Research still carries Floyd Sweet's technology. I did a presentation on Floyd Sweet about 4 or 5 years ago, okay? And I'm working with some of his schematics where he's got two opposing coils creating the scalar wave phenomena, okay? And Tom Bearden spoke about the Floyd. He actually saw Floyd's device. He was able to witness Floyd Sweet's device in person, okay, watching it operate. And Tom was saying that the device lost like 90% of its weight, produced like 10 million% efficiency. He had near zero input current on his device. And I mean, when you look at it, it looks conventional, okay, except that the two coils are set up in this opposing configuration. There are photos of Floyd's device out there on the internet. I presented a few of those photos in my lecture, okay, that I gave at Tesla Tech, okay, on Floyd Sweet's device. And so you see this 90% weight loss in his device. Now, another researcher by the name of John Hutchison perhaps many of you heard of John Hutchison, was able to levitate a 90-pound bowling ball or cannonball, okay, with this technology. And you see all this stuff flying around in his lab when they expose with these converging Tesla. He was producing all these Tesla beams or radio wave signals in his apparatus. And another device that comes to mind is the German Nazi Bell device. I don't know if many of you have heard of that. It's out there on the internet, where they set up converging spinning magnetic fields called the Glocke, I believe is how you pronounce the Bell device that the Germans built during World War II. And that device was actually tested in Poland. Poland at a concentration camp is where they set up that test apparatus. And there was a fellow by the name of I forget his name, but he spoke about the machines of the Wunderwaffe. Okay, and I think that book is still available, but you need the original print. Okay, if you're going to look at the original description of the Glocke, that's what you need to look at, because they set up these counter-rotating fields, okay, in this device that's bell-shaped, and they use DC current, okay, and that's very important, is that you have to use a DC opposing magnetic flux, and then you spin these, you counter-rotate these spinning magnetic fields to get that cancellation effect going on. So that's what all these devices are using, is a canceled magnetic field, okay, to produce this anti-gravitational effect.
You mentioned that.
Okay, another question here. Any?
Right.
Okay, now personally, I have not observed anything over 100% in my technology, and that's because the coils are not tuned, okay, in my device. And I'm still working on that part of it. This last year here, I've been spending a lot of time writing the software to do all these calculations, okay? But there's a next phase to this that I definitely want to get into with the scalar technology. And that's a form of scalar interferometry, okay? Not to transmit, okay, but to produce on the test bench. And so my next phase of operation here, okay, is to produce this interferometry test system that I want to work on, and that's what I want to produce a real AC wave with, okay, this high potential. And so my next phase is working with that technology.
Very good. Are there any other questions? Right. So, Bill, do you see the question, right?
Yes.
Can you share some values
okay,
to
the
extended
test.
Bushman drop test experiments, right?
I have some videos that I took a number of years ago on this drop test. And what Boyd Bushman spoke about, you know, in David Sereta's video, is that he described quite thoroughly, you know, his opposing magnet test when he dropped these magnets down an elevator shaft over at Lockheed. Now, I do know that Lockheed extended, built some machinery, okay, to further develop Boyd Bushman's concept here. And I think he's got some patents out there Boyd has some patents out there as well. But what you want to replicate, and this is what other researchers have done as well, is to replicate Boyd Bushman's original drop test. And I extended it using magnets in just the opposing configuration. Of course, they come together. Okay, the magnets are, neodymium magnets, and it's exactly how I described that. They are quite dangerous to work with. Okay, and I kind of wrapped them up with some electrical tape. And then what's interesting about this is that they dilate time, okay, with this technology. And, I did a number of experiments at a place called the Mystery Spot, okay? I even developed mathematics. I call it natural relativity. Einstein calls it his general relativity, working with tensor type physics. Me, I just work with regular exponential functions, okay, and I call it natural relativity. But I came up with something that converts time, okay, which to me is what gravity is. It's the tick rate on your clock that changes. Now that tick rate can either increase or decrease depending upon how the curvature is occurring. And so if the tick rate is increasing, that's your anti-gravitational effect. Okay, it's blue shifting. But if it starts to slow down, that's your red shift. Okay. Now, what's so interesting? You could put this you could put all this to the test. Okay, you can test it, and the place to test it is a place called the Mystery Spot in Santa Cruz. And there's a number of these mystery spots along the coast, along the West Coast. Now, why this phenomena occurring is a mystery, and that's why they call it the Mystery Spot. Okay, you can look this up on the internet. This place is in Santa Cruz. You can go there and test it, and what you observe is something called the shrink-grow phenomena. Okay, where people, they change positions and their height. They either grow in height or they shrink in height. And you can actually see this phenomena occurring. Okay? You can see it. It's demonstratable. And then I developed some technology that measures that phenomena. And a lot of psychologists want to write it off, as an illusion. It's not an illusion, this phenomena. This phenomena is not an illusion. Okay, it's for real. And you can measure that phenomena, but how do you measure the shrinking phenomena or growing phenomena? How do you measure that? Well, you can't use a yardstick to measure that because your yardstick is going to shrink or grow with you. So the only way to measure that phenomena is with time. Okay, you look at the dilation effect, and of course, when something grows, that indicates a blue shift. If it shrinks, that's your red shift. Okay, and you can actually see that in time, that shifting phenomena. Okay. And so you look at the shift and you feed it into my gravity equations, and lo and behold, okay, you find out what your shrink-grow phenomena is. Okay, I know it sounds crazy, but it's for real. Okay, and this is what you use to measure gravity is time dilation. Okay, so
very good.
that's
So,
my presentation.
thank you for your questions and thank you for your answers, Bill. So it was excellent. Thank you a lot, and I hope to see you soon.
Yes. carry on.